Let's talk about solving absolute value inequalities. First, we need to know that a compound inequality is two inequalities combined by the words and or. Absolute value inequalities result in a compound inequality because, just like absolute value equations, there are two parts we have to consider when we solve it. When the absolute value is isolated and the variable is on the left, and we have a less than or equal to symbol, we're going to get back a compound and inequality. What helps me remember this is less than. So if it's less than, we get x is in between two numbers. So it's an and inequality. We have a lower boundary is less than or equal to x, which is again less than or equal to the higher boundary. If, when the absolute value is isolated in the variable on the left, we see a greater than or equal to symbol, we get an or compound inequality. I remember this by thinking great or, and it looks something like this. X would be less than or equal to our lower number, or it will be greater than or equal to the higher number. So let's try one. So what is the solution to the absolute value of x plus 4 is less than 2? And then we're going to graph the solution set on the number line provided. We do have a checklist for solving this algebraically. We want the absolute value isolated, just like we did with our equations. And it is. So we can check that off. Is the variable on the left? It is. We can check that off. To figure out if it is and or, well, since we've already marked off our first two items on our checklist, we see that it's less than, which means it's an and inequality, which means x is going to be in between two. And we don't have a line under our original problem, so we don't have a line under it now. So it's just going to be less than instead of less than or equal to. So we can mark out B and C because those are not and compound inequalities. That step is done. Next step, drop the absolute value symbols and solve for the first inequality. Very similar to what we do with absolute value. We drop our absolute value symbols. X plus 4 is less than 2. Box in our variable, line down. Use our inverse operations to get rid of everything else except the variable on the left. Minus 4 on the left and on the right. Same thing on both sides. The 4's cancel. 2 minus 4 is negative 2. On the left side, I still have x, and I didn't do anything that would cause that symbol to change. I did not divide or multiply by a negative number, so it is still less than. So x is less than 2. So this has the point towards x on our symbol, so we know negative 2 is going to be our upper boundary because x has to be less than that, and we can fill that in on our answer. That step is finished. Last step, for the second inequality, we drop the absolute value symbol. We keep the left side the same. We switch the symbol and make the right side negative. So, while it's very close to what we do for equations, we have to remember to flip the symbol as well. So, that x plus 4 is less than 2, we change to greater than negative 2. Box in the variable, draw our line down, use our inverses to get rid of our 4. So minus 4 on both sides. The 4's cancel. Negative 2 minus 4 is negative 6. On the left, x is now by itself, and we didn't divide or multiply by a negative, so our symbol does not change. Now you see the open end of our symbol is with x. X has to be greater than negative 6. So negative 6 is our lower boundary number, and that can go into our answer choice. So that step is finished, and we have solved our problem. That means our answer matches A, negative 6, is less than x, is less than negative 2. Now, let's graph it on the number line. To graph on the number line, I'm going to put an open circle at -6. Remember, we don't have the or equal to part, so we don't fill in the circle. So an open circle at -6. We have an open circle at -2. And we connect them. We're going to fill in between because x is in between those two numbers. And we have our answer. Let's try another one. Solve for x, graph the solution set on the number line provided. We are still going to use our checklist. First step is the absolute value isolated. It is not. We have to fix that. I need to get rid of the 2. What I do is I box in the entire absolute value when I have to fix it and get the absolute value by itself, because that's what we're solving for, just like when we solve for x. So let's box it in. I see I have to get rid of my 2. It's 2 times, so I want to divide by 2 on both sides. My 2's cancel. On the right side I have 6. 12 divided by 2 is 6. So now my absolute value of x plus 2 is by itself. I didn't divide by a negative, so my symbol stays the same. Now it is fixed, and I can move on to step 2. Is the variable on the left side of the inequality? It is. Step 2 is good. Let's move on to 3. Is it and or? Less than, great or. I see greater than, so it is or, which means x is going to be less than or equal to a number, or x is going to be greater than or equal to a number. Next step, drop our absolute value symbols and solve for the first inequality. So x plus 2 is greater than or equal to 6. Box in my variable, draw our line, use my inverse operation. So I have a plus 2, I want minus 2 on both sides. My 2's cancel. 6 minus 2 is 4. Now I have x by itself on the left, and I didn't do anything to change my symbol, so it's still greater than or equal to 4. Last step. For our last step, we drop our absolute value symbol, keep the left side the same, switch the symbol, make the right side negative, and solve. So we take our inequality, we keep the left side the same, we switch the symbol and the sign for 6. So it becomes less than -6. Box in the variable, draw our line. We want to get rid of plus 2, so we have to use minus 2 on both sides. Our 2's cancel. On the right side, -6 minus 2 is -8. On the left, x is now by itself, and I keep my less than or equal to, since we didn't do anything to change the direction of that symbol this time. So we now have our answer. X is less than or equal to -8, or x is greater than or equal to 4. Let's plot that on the number line. I'm going to draw a circle at -8. Since it's or equal to, it's a closed circle. And then I draw the line on my number line towards the same direction that that point is. So I have this pointed towards x, so it's going to go towards the left this way, that direction. On the right side, for x is greater than or equal to 4, we need to draw a closed circle at +4. We see that our arrow is pointed towards the right. So from here, I'm going to draw my line out to the right, the same direction as the point. Problem solved. All right, let's pause here to practice.